apologise for that. My name's Peter Dyment. I work for Camphil, and as we rapidly go through to where I was just mentioning about the benefits of air quality in terms of improvement in people's working performance, when you consider people have a very high economic value in most working environments, companies, typically 80% or above, it's very important they work at a high level of efficiency. And studies have shown that if you're talking about clean air and the effects of air pollutants, then they can have a very marked negative effect on people's working performance. And it can have both a conscious effect and an unconscious effect, and that's been demonstrated by many studies, which I won't sort of go into in great detail here, as they have been previously mentioned. So what we want to try and do is capture the benefits of good clean indoor air quality within the building, and considering we spend about 90% of our time inside buildings these days, it's important to try and come up with a method by which we can achieve clean indoor air quality. And it just strikes me that these days there's a lot of work being done to monitor levels of energy performance, energy consumption in buildings, and the same principles of ISO 50001 could be applied, well applied, to monitoring and checking of indoor air quality as well. There have been several recent articles, in fact, querying the fact that a lot of time is spent monitoring energy and maybe neglecting air quality and indoor air quality. I've done a fair amount of particle counting in the London area, as you can see from the photo here, and looking at the package that needs to be achieved in terms of delivering clean indoor air quality. It's obviously the air has to be introduced into the building in a clean way. Temperature and humidity are important issues, which I won't dwell on as much as others have, but just to say that that is the case. Carbon dioxide and ventilation rates are very important. Carbon dioxide levels have to be minimised and oxygen has to be replenished in the building. An airtight building envelope is obviously an issue these days. Modern buildings are somewhat better designed than many of the older buildings, but older buildings have to be refurbished. Planned maintenance has also been mentioned, the fact that if you have air conditioning plant, it has to be regularly looked after and serviced. So what's in the air that we don't necessarily see? Well, there are a whole clutch of particulates in terms of pollution and gas phase pollutants, some which have very harmful effects, some less so, but the particular ones that cause most harm, according to reports, World Health Organization research, fine particles, PM 2.5, oxides of nitrogen and ozone are certainly three of the most important ones to consider. So if we're looking at that, then it would make good sense to monitor PM 2.5, keep the levels low, nitrogen dioxide, ozone, sulfur dioxide, oxides of, and there are recommendations given in the standards, European standards. EN 13779/2007 gives you indoor and outdoor air quality bandings, which you can look into and see whether you're selecting your air filters, which have the air filter test standard EN 779/2012. That gives you the classification. EN 13779 gives you the recommendation for selection. So if you get that right, so that you've actually got filters that will remove the larger part of these troublesome, in fact hazardous pollutants in the background air, then you will be some way towards tackling the problems that are going to be experienced. Again, I won't spend a lot of time on temperature and humidity and replenishment because those have been mentioned previously. Checking the building envelope has low leakage. There are tests that can be done on that. And checking the HVAC plant is fit for purpose. I do a lot of work with air conditioning inspections and it is surprising the numbers of plants you come across where there is very poor condition of plants, poor maintenance, and change of purpose of building plants, which should enable not just energy efficiency savings, but possible re-engineering for better clean indoor air quality as well. There's also a big freedom of information now. You have London, for example, here, publicly available information on levels of, in this case, PM 2.5. And you can just see here, if you amalgamate some previous studies, for example, the 6-city survey, the American survey, this is probably slightly controversial, but here this does give you an index of increase in concentration of fine particulates and mortality rate increase. When you apply those index links to this data here, you can actually read off, for example, that people in the blue areas of London here are probably experiencing a 10 to 15% increase in the mortality rate. We also have World Organization guidelines for these types of pollutants, as you can see, and for this 10 micrograms per meter cubed annual value, it's obvious that many of the large cities, not just London, are greatly exceeding their World Health Organization limits. And when you consider that PM 2.5 is a group 1 carcinogen, maybe it's something that should be very carefully considered. And in fact, the health aspects are that fine particulates will make deep penetration into lungs. This is a human lung cavity showing such a particle in situ, where they do a lot of damage, causing increase in diseases. And not just the particulates, but also the nitrogen dioxide, ozone, other benzene, VOCs, and assorted other background pollutants. In fact, it's interesting to look at the sources of pollution. You get the outdoor source pollutants and the indoor source pollutants. And it's also interesting, I won't go into the health vent details in great detail, but I was very surprised when I saw this slide, which indicates that about 1/3 of the burden of disease comes from indoor sourced air pollutants and about 2/3 from the outdoor sourced air pollutants, which would indicate to me, from an air filtration point of view, or introduction of ventilation air into the building, it should be very well filtered to take out as much of these health damaging air pollutants as possible to reduce this burden of disease. And when you actually look at the other slide that I came across here, it actually does show that air filtration is a very effective way of reducing this indoor air pollution. Of course, it's been mentioned that outdoor air does come into the building, and so it will carry this pollutant with it. And apart from actual source control, which is again a very important part of an overall strategy, mechanical air filtration is very much a necessity. Some of the work I've done in buildings have been involving particle counting, both indoor source points of testing and outdoor source points of testing. You can see the data here, and what this really just shows you is that you've got numbers of particles here in various different sizes. The respirable particles are the ones that are small in this range, 0.3 to 0.5 micron. And you can see here the indoor sources, or the indoor locations where the particle counts have been made, are much lower than the outdoor source in general. And this gives you the beneficial effects of having good indoor air filtration systems that are working well and an airtight building envelope. And this reduction benefit here will, of course, greatly reduce people's exposure to this rather nasty toxic background combustion air pollutant, the particulates from traffic. If you wish to have protection from the NOx and SOx gases, of course you would require gas phase filtration, which can be, of course, fitted and will have efficiencies of typically 80 to 95%. So there is a solution both for particulates and gas phase pollutants. This is just emphasizing the sources of advice. World Health Organization is really the primary source on medical and health aspects, and should be followed. It's possible to have background air pollution testing, both indoor and outdoor. Indoor pollutants can, of course, contribute to people's health. We've heard about sick building syndrome, and there are kits readily available that can take tests for a wide variety of VOCs, formaldehydes, other commonly experienced pollutants that may be a problem for sensitive people. In terms of products, specific products, there are a wide range of products available, both particulate filters that are selected not just for their effectiveness at taking out particulate, but also low operating pressure drop and low energy consumption. We have combination filters that include not just particulate phase, but gas phase, both in a sort of bag filter format, but also compact filter. And we have just carbon filter or gas phase filtration units as well. These are designed specifically, again, for low operating pressure drop, so they are extremely energy efficient, as well as delivering the required efficiency for removing pollutants inside the building. So apart from just having main systems, a lot of us don't live in or work in offices and working environments where we have large centralized systems. There are solutions available which can take into account you might have a small room or area in a building that might need air scrubbing or air cleaning to a HEPA class filter system. And you can actually use these units. You can see here that this has a side vent, so you can actually draw air from the outside into the building and take it straight through the air filtration process, as well as recirculating the air inside the building. So there are solutions that mean that even when you have a lot of air pollution outside the building, you can actually maintain a very clean indoor air environment. And these have also been used in hospitals, for example, where Aspergillus virus from nearby buildings being demolished has caused a health risk, particularly to children in children's wards. You can install these units and take out that problem, as well as background air pollution in general. So there are a wide range of standalone solutions as well as centralized air filtration for air systems. Just to quickly mention again about inspection of ducting, we've seen some pretty appalling shots of ducting and rubbish and deposited dust and dirt. Well, we now have a European standard which again enables us to specify on building purpose here the recommended inspection periods, which are typically 1 year between visual inspections and reporting on the condition and air hygiene quality of the ducting and whether it requires attention. So that is something else that is being dealt with. Air tightness testing for building envelopes again is something which is now available and can be utilised either in a retro situation or a new build, so that you can be aware of the either reduced or increased ventilation rates that may be required to deal with that situation. So we really have a package of measures now which are there in place, and if we pay attention to all of them, we can actually come up with a very good solution which will cover all the requirements. But of course, air filtration is something that has been little considered by many people, which now, thanks to the better control technology we have available, we can actively monitor indoor air quality much better than we have previously been able to. So thank you very much. I'll leave that for questions.